Okay, today you should continue where you left off yesterday. So hopefully you did your speed and velocity screencast. If you need to finish the speed and velocity Schoology practice, go ahead and do so. Today you have the interpreting speed graph screencast and notes, lab, and Schoology practice. Distance time graphs. We're just adding speed into it now. So it still shows the same thing. So what did your distance and time graph show? It showed how an object moves over time. So think to your math class now. And how do you calculate slope? Slope is equal to the rise over run. Or if you think about it, y over x. What is the rise on this graph? What is your y-axis? Our y-axis here is distance. What is the run on this graph? Remember, the run is your x-axis, and that is time. So your slope here is equal to distance divided by time. How do you calculate speed? If you remember that from our previous screencast, speed is equal to distance divided by time. Therefore, what does the slope represent? The slope is equal to your speed. If you calculate the slope of any of these lines, you will calculate how fast the object is moving. So let's take a look at this. How do you know which object is moving the fastest? By just looking at a graph. It happens to do with your slope. So as we keep looking at our slope, the steeper your slope, the faster your object. So which object is going the fastest? The yellow square line is going the fastest. And how do we know that? So the steeper the slope, which means your most vertical line, or your line that goes most up and down, the faster the speed. So let's take a look then, which object is going the slowest? So think the opposite of that now. So your red triangle line is going the slowest. And how do we know that? The flattest line. So in other words, the most horizontal, or the most left to right, is the slowest speed. And just for review, are these objects going away or coming towards? Remember that we always put the observer down here. So as time goes on, each of these lines is increasing in distance over time, meaning that your objects are going away because the distance is increasing over time. How do you determine whether something has positive or negative velocity from a graph? So first, let's review from before. which line is going the fastest. Your yellow circle line here is going the fastest because it is the steepest, right? The most up and down, the most vertical. Which object is going the slowest? In this case, it's your red square line. How do we know? Because it is the flattest line, the most horizontal, going left to right. Are the objects moving away or coming towards? Are all your objects doing the same thing, or are they different? So as we take a look at which ones are coming away. So which of your objects are moving away? Which ones are increasing distance over time? Which lines are going up? So your yellow and blue are going away. What about coming towards? Do you have any lines that are going down with decreasing distance over time? You have the red. Okay, so now let's talk about this new concept of positive velocity and negative velocity. Remember that velocity depends on direction. So the objects that are going away, that have a positive slope, have a positive velocity. So again, your yellow and blue have a positive velocity. So how do we know? So positive velocity equals positive slope, which means your line is going up with increasing distance which we've mentioned before that this pretty much means we're going away. All right, how do we know which ones have negative velocity? Your negative velocity is the red line. So how do we know this? So negative velocity has a negative slope, which means that your line is going down with decreasing distance. And that would mean that it is coming back towards. So let's take everything we've talked about between distance and speed and velocity and describe the motion that is happening on these graphs. So describe the motion of the yellow star line. So that's going to be this line, okay? And what's happening over time? Is it moving away or is it coming back towards? So it is moving away from the observer at constant speed. So this is a new thing here, constant speed. Okay, constant speed is a linear line. If you remember that from graph, it means that your line is going straight up or straight down. Okay, so our yellow one is moving at a constant speed away from the observer. It is moving with positive or negative velocity. Remember that it's going up and moving away, so it is moving with positive velocity. Okay, let's take a look at the green line. So our green line is the one with the circles right here. Okay, so is it moving? Is the distance changing over time? No, it's at 20 the entire time. So here, our object is not moving because it's a completely flat line. So if we're a completely flat line, what is our velocity doing? We have no velocity. There is no speed, there is no movement, there is no velocity. Let's take a look at the blue line. So as we take a look at the blue, first thing to decide, are we moving away or are we coming back towards? Overall, your line is going up. So we are moving away. So our yellow line, that was moving at constant speed because it was a linear line. What about these lines that curve? That would mean we are changing speed. Okay, so this particular line happens to be curving up, so it's moving away with increasing speed, right? Because it curves up. So what does that tell us about our velocity? Do we have positive velocity or negative velocity? We have positive velocity because our line overall is going up with a positive slope. And let's describe the motion of the red line. Okay, so overall, are we increasing with distance over time or decreasing? Our line is coming down. So we're decreasing distance, which means we're coming back towards the object. And if we think about it, are we constant or changing speed? So is it a linear line or does it have a curve? It has a curve, so it's changing speed. And this one is curving downward, so it's actually coming back towards with decreasing speed. Okay, so do we have a positive velocity or a negative velocity? Remember that because overall it's coming down, it has a negative slope, so it has a negative velocity. Okay, last but not least, we need to cover how you calculate slope from a graph. So first we're going to remember, what does slope on this graph represent? When you are calculating slope, you are calculating speed. Okay, so what is our equation to calculate speed? That is distance divided by time. So as we take a look at this, what is the speed between 0 and 10 seconds? All right, so speed is equal to, remember if we really break this down, slope, we're going to get into y2 minus y1 over x2 minus x1. So, taking a look at this first example, 0 to 10. So I'm looking at this part of my graph. So my y2, where am I ending? Okay, we're ending at 10. So it's going to be 10 minus, where are we starting? For my y, we're starting at 0, divided by, what was our time frame that we're doing? 10 to 0. So 10 minus 0 is 10 minus 0 is 10. 10 divided by 10 is 1.0 meters per second. Don't forget the unit. And remember, on the test, you will be required to show your work. All right, let's take a look at what is the speed between 10 and 30 seconds. So we're going to go from 10 to 30 seconds. All right, so I'm going to go up from 30. Where are we ending? We're ending at 10. So speed is equal to 10 minus, where did we start? 10 over, what was our time frame? 30 to 10. So 10 minus 10 is 0. 30 minus 10 is 20. 0 divided by 20 is 0 meters per second. And that makes sense, right? Because we said that we have no movement if it's a flat line. So we shouldn't have any speed. Okay, next section. What is the speed between 30 and 50? So we're going to go from 30 to 50. So if I go straight up from 50, where am I at? I am at 40. So my speed is equal to 40 minus, where did I start? 10 divided by, what was our time frame? 50 minus 30. So 40 minus 10 is 30. 50 minus 30 is 20. And 30 divided by 20 is equal to 1.5 meters per second. All right, let's do the next part of the graph. What is the speed between 50 and 90 seconds? So we're going 50 to 90. So where are we ending? We are ending at 0. Where did we start? We started at 40. And what's our time frame? 90 to 50. So 0 minus 40 is 40. 90 minus 50 is 40. 40 divided by 40 is 1 meters per second. Okay, now some of you might be asking, where does the negative go? Remember that speed cannot be negative. Okay, speed always has to be positive. So as we take a look and analyze this a little bit further, are the speeds at 0 to 10 seconds and 50 to 90 seconds the same, or are they different? So between 0 and 10, we said it was 1.0 meters per second, and 50 to 90, we said it was 1.0 meters per second. So that would be, they are the same. Even though on the graph, we're going in two different directions, the overall speed, which is just our numerical value, is the same. All right, let's take a look at, would the velocity be the same as the speed between 50 and 90 seconds? So let's go through and just take a look at all of our items here. So in the very first one, the speed between 0 and 10, did we have a positive velocity or a negative velocity? Overall, our line was going up, so we had a positive velocity. Between 10 and 30, we have a flat line, so we had no velocity. Between 30 and 50, overall our line is going up, so we have a positive velocity. But what's happening between 50 and 90? Our line is overall going down, so we have a negative velocity. So let's look back at that question. Would the velocity be the same as the speed during our 50 to 90 time period? So we said here that our speed was equal to 1 meters per second because speed cannot be negative. It has to be positive. But what about our velocity? Velocity is directional, so that positive and negative matters. So our velocity here would be negative 1 meters per second. So they would not be the same. Now you have a speed and velocity lab. So you completed notes, a partner, a pencil, a ball, and a meter stick from the teacher. Read the instructions on the lab sheet and complete the measurements and questions. Hang on to it because you get to use this packet on the test. Then complete the speed and velocity Schoology practice. Use your notes.